Today I am going to teach electrochemistry from NCERT book. From the left side there is a column which describe in summary that the topics covered in this chapter, and today we will discuss this topic. Describe an electrochemical cell and differentiate between galvanic and electrolytic cell. So first we have to know what is electrochemistry. Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reaction, and the use of electrochemical energy to bring about non-spontaneous chemical transformation. That means in the electrochemistry, for spontaneous reaction, the chemical energy transform into the electrical energy, and for non-spontaneous reaction, we have to put electrical energy for the chemical change. The use of now the we have to know what is the use of electrochemistry in day-to-day life. It is used in battery and fuel cell to convert chemical energy into the electrical energy, and are used large scale in various instruments and devices. The reaction carried out electrochemically can be energy efficient and less polluting. Therefore, the study of electrochemistry is important for creating new technologies that are eco-friendly. So now, as you see that in electrochemical cell, there are two type of electrochemical cell. One is Daniel cell or Daniel cell or galvanic cell, and which is also known as reversible cell. And the second type of cell is electrolytic cell, which is also known as the non-spontaneous and irreversible cell. So here the simple description given about the Daniel cell and electrolytic cell. Here we can see that the simple Daniel cell, where this side a zinc rod used, and in this side a copper rod used. For this, the zinc salt solution such as zinc sulfate can be used. Here copper sulfate solution can be used, and both the half cell reaction are connected by salt bridge. Here the electron flow from this side to this side, and the current flow in the reverse direction. The current flow in the reverse direction. So the current flow from this side to this side. And here the representation of redox reaction for the Daniel cell is given: zinc plus copper 2 plus to convert zinc 2 plus to copper solid. Here for the electrolytic cell, if the external opposite potential is applied in the galvanic cell and increased slowly, we find that the reaction continues to take place till the opposing voltage reaches the value 1.1 volt. That means until it reaches to the equilibrium, it there is a chemical transformation occurs. When the reaction stops altogether, no current flow through the cell. So when this voltage 1.1 volt voltage potential difference between the two cell reach, that means in this situation no current flow of electron or current occurs, no chemical reaction occurs, because in both the side the potential difference reaches at its equilibrium, so no reaction occurs, and that's why no current flow occurs. But when the reaction and any further increase in external potential again start the reaction, but in opposite direction. So it is now function as a electrolytic cell. So this this is the typical example of electrolytic cell. So we can see, we can understand here, if we if the potential difference, this is the potential difference is less than 1.1 volt, and we apply the external potential, so the electron flow from this side to this side and the current flow in opposite side. This is electron flow from zinc rod to copper rod, hence current flow from copper to zinc, and zinc dissolve as anode and copper deposit as cathode. And when the external potential and the internal potential are equal, when it is external potential is 1.1 volt, no flow of electron or current, no chemical reaction occurs, and so we can see that the I equals to 0, that means current equals to 0, and there is no reaction occurs between the zinc rod and zinc sulfate solution. And if we increase the potential difference, external potential difference, external potential that we see, then the opposite reaction occurs. That means the electron flow from copper to zinc and current flow from zinc to copper, and zinc is deposited at the zinc electrode. Here zinc is deposited as zinc electrode and copper dissolved at the copper electrode, and copper rod become thicker. Copper rod, the size of copper rod get reduced. So here there is a chemical conversation for when, as you know, the Gibbs energy related with the chemical energy for spontaneous reaction. Whether here we know, as we know, that the Gibbs energy is the indication of spontaneity of the reaction. That means if the Gibbs energy is negative, the electrochemical reaction is feasible, and if the Gibbs energy is positive, that means it means the chemical reaction will not get occur. We have to put the external potential to get occur the chemical reaction. So this is the typical Daniell cell, and for the half cell reaction, you can see that as here copper 2 plus get reduced to copper, so it is in the reduction half cell, and zinc 2 plus oxidized to zinc solid oxidized to zinc 2 plus, so it is in the oxidation half cell. Here the typical example of the electrode potential is given. The potential difference developed between the electrode and the electrolyte, which is called the electrode potential. When concentration of all the species involved in a half cell is unity, then the electrode potential is known as the standard electrode potential. This is And here given the UPAC convention, the standard reduction potential are now called standard electrode potentials in a galvanic cell. The half cell reaction in which oxidation takes place is called anode, and it has a negative potential with respect to solution. The other half cell in which reduction takes place is called cathode, and it has a positive potential with respect to solution. We have to know the UPAC convention also. Here the potential difference between the electrode of galvanic cell is known as cell potential and is measured in volt. The cell potential difference between the electrode potential reduction potential, that means in reduction potential of the electrode cathode and anode, it is called cell electromotive force or EMF force of the cell when no current is drawn from the cell. So cell potential here for a galvanic cell is generally represented by putting vertical line between the metal and electrolytic solution and putting a double vertical line between the two electrolytes connected by a salt bridge. So it is a typical representation of galvanic cell. Here we can see that the for electrochemical cell, total cell is depended by E right side minus E left hand side. This is illustrated for this reaction. Copper electrode plus aqueous silver electrode, where copper get oxidized and silver get reduced. As we know that for the reduction, as we know the cathode is the reduction occur in cathode. So Ag plus capture two electron and get reduced to a silver, and oxidation take place in anode. So copper get oxidized to copper 2 plus will be in the anode side. So here we can represent that copper to copper 2 plus, that means oxidation take place in left hand side. So we can represent it in left side, and here vertical line, the double vertical represent the salt bridge, and the right hand side Ag plus get reduced to silver, silver plus get reduced to silver. Here we have represented the total cell, E right hand side minus left hand side. So as we know that the reduction side will be in left side, that means silver plus to get to silver is in left side, and the oxidation or the anode side will be here. We can see that the total cell representation E right hand side minus left hand side. Here as we can see that the cathode or the reduction potential reduction side will be given in the right hand side, that means silver plus to silver is in right hand side, E right. Here E right, we can write it here, and the oxidation side or the anode side, that means copper get oxidized to copper 2 plus will be in left side, E left. Here we represent E left,